So the next part of 4.1 is looking at trigonometric ratios in complex situations. So basically, what's going to happen is we're going to get a bunch of right triangles all stuck in a jumble together. So if we look at this next example, we can see, well, there's a big right triangle, this triangle QSP, right in here. There's a smaller triangle in here, triangle STR. And then there's also these little triangles off to the side. RTQ is a right triangle, as well as QTP is another right triangle. So a complex situation just gives you some time that you're going to have to do some multiple steps or solve some things in which you can move on to the next step to get things you want. So we're looking to solve for QS, which is right along here. QS is the length of the big triangle on the outside. And we actually know some key informations. We know this angle S is 20, and we know this side length PQ. So realistically, we know an angle and a side length, which means we can solve for all the other side lengths in a right triangle. So we can solve for QS right away. Then they said they also want to know about this length ST, which is this partial one here, ST. So it's the smaller triangle, still with angle 26, but at this moment we don't know any of the other side lengths or anything in this triangle, so we can't solve for ST right away, but we should be able to solve for it eventually. The last one that we're looking at solving for is length RT. RT is right here. It's also part of this triangle here, but it's also a part of this little triangle in here as well. Okay, so we'll keep about trying to figure out how we can do a couple things and see where it goes. The first one I definitely know that we can do is solve for QS. So we know in this big triangle, angle S is 26, and the side opposite to it is 12.5. And we want to find QS, which is in this big triangle. It's not the hypotenuse, because the hypotenuse is over here. It's SP, the hypotenuse. This is the adjacent side. So if we have adjacent and opposite, we have tan. So tan of 26 is equal to 12.5, which is opposite, over QS, which is my adjacent. Some people like to use QS. Other people will write X right here. So to solve for it, so you will probably, and lots of people, like to put the tan of 26 over 1. And so then when we cross and multiply, we get 1 times 12.5, which is just 12.5, and we get QS times the tan of 26. So then to get tan of 26, or QS alone, we divide by the tan of 26 on both sides, and we get QS to be a length of 25.6. So we've got this big long length to be 25.6. A lot of times when I figure things out, I come back and I write it into the picture. Sometimes it makes it easier to see the next kind of step. So we've got length QS. Now, to find ST, let's go back and look. Where is ST? ST is in this triangle here. But some people have a hard time seeing, and I'm going to highlight it here in pink, so you can see this triangle that they want us to see. They're looking at this. Sorry, I'm going to highlight it in pink. They're looking at this triangle right here. Right here. The reason they want to look at this triangle right here is the fact that this is a right triangle right in this corner here, because this is a right triangle and it's a straight line, so there's a right triangle on this side. So I'm going to just erase this so we can see the triangles again. So what we are looking at is this triangle here. This is a 90 degrees right here. So this 25.6, because this is part of this triangle we're looking at, right? Right here and here and here. This 25.6, it's across from the right angle. So this is your hypotenuse. And this 26 degrees is part of this triangle. So we've got an angle and a side length. So we can solve for all the other side lengths. We're looking at ST, which is this length over here. So that's adjacent to the 26, and this is the hypotenuse. So then we're dealing with we're dealing with cos. So the cos of 26 is equal to our adjacent side, our unknown, divided by our hypotenuse, our 25.6. So I would put this over 1. Cross multiply, I get the unknown length ST is equal to 25.6 times cos, gives us 23 centimeters. So if we go back here, now we can call this 23 centimeters. Just this length ST, 23. So our last one is to find RT. Now, if I erase what I've got here, now we're looking for RT now, remembering that 23 is only from S to T. That 23 is only from here to here. Ooh. You can see that RT, what we're trying to solve for, is part of a triangle with this new length we found. It's part of this tiny little triangle on the top. RT is across from 26, is opposite to 26. And this 23 in this triangle, our right angle is right here. The 23 is our hypotenuse. So we want to know the opposite side from 26 with a hypotenuse of 23. That's sine. Sine equals opposite over hypotenuse. So we'll take the sine of that angle is equal to opposite over hypotenuse. So the sine of 26 is equal to RT over 23. That's the hypotenuse. We can put the sine of 26 over 1. We cross multiply. We get RT is equal to the sine of 26 times 23. When we work that out, it's about 10.1. Okay? So it's all about working with triangles and trying to figure out, so if it's got a right triangle on one side, you know it also has a right angle on the other side if it's attached to a straight line. Like in this question we have 3 actual triangles, but realistically we have this right triangle here and we have this right triangle over here. I'm going to guess you're going to have to use this triangle to solve for our length in here, like the height. And now we'd have the height of this triangle, so we'd have 2 side lengths, and we can solve for that third side length. But go ahead and try these, build your skills, and then join me back for some more of 4.1.